Hello and welcome. In this video, we are going to explain how the GAN works. GAN is of course, the first type of AI that generated something new, something considered to be innovative. So let's understand how it works. The idea of GAN is we have two types of AI. The first one is a generator. The second type of AI is a discriminator. The generator is going to create a fake images. In this case, a 5,000 yen currency, he's trying to fake this currency, an image of this currency. On the other hand, we have a real data, a real images of currency, and the discriminator job is going to look into the two images, the two currency images, and realize which one of them is real and which one of them is fake. The discriminator always tries to predict the correct thing, that is, identifying which image is real and which image is fake. The generator, on the other hand, will try to fool the discriminator by creating better and better versions of this image of the currency that mimic, well, in this case, 5,000 yen coin or like currency. This GAN network is published in 2014 by the University of Montreal, and it did make a big impact in which AI can now make new images from random noise. So in regards to AI, well, methodology or speaking, how does this method works? Well, it starts by creating a random noise. Creating a random noise in here, and later what we will do is we will generate an image from this random noise, making a fake image. On the other hand, we have also data that is real images of, in this case, numbers. What we will do is the discriminator will read both the real and fake images and will decide which is real and which is fake. Bear in mind that the generator itself doesn't really know or see the real images. He doesn't see it. What he only gets as a feedback is a feedback from the discriminator that this image is real or fake, well, which is the probability of this image to be real or fake. So the generator will change the numbers in the weights in the generator itself in order to create better images that mimic the real images. So as I say again, there is no real, the generator never going to see directly the real images. The only thing he will do, or well, he will say it will do, is changing the noise pixels to get better result from the discriminator that this image is possibly is more real than fake. Of course, this is the simple way of GAN. However, it become more and more complex, and we can see that more complex networks is being here, and some of them will require, or you will input an image, and the GAN network will try to generate a super, for example, high resolution image, or for example, removing rain in this image, or some snow falling in the image they try to remove to generate a new image that will deceive the discriminator. So this is basically how this network working. Well, now what we need to understand also is what the generator and discriminator kind of loss that they are trying to reduce. Well, the generator loss is basically is trying to get his images to be ranked as real. That's it. And the discriminator will try to have, or the loss of the discriminator is very straightforward. Well, basically, we'll have two kinds of images, real and fake, and he has to classify them into the correct classes, which is the real class and the fake class. So the loss in GAN, or the equation that's stated by the paper in 2014, is basically a min-max loss function that we're trying to basically optimize. So going to the first, the generator, well, we're trying to minimize the value in which the first one is going to be the average log likelihood that the real image is going to be classified by the discriminator as, well, if in the generator uh, position, he's trying to classify it as, let's say, 0 as fake rather than 1, which is real. So he's trying to make the discriminator be confused that a real image is just going to be fake. On the other hand, what which is this denoted by dx, which is the output of the discriminator, x is the real data. On the other hand, the other part of the equation, this part, which is the likelihood of 1 minus the prediction of the discriminator that the image generated by the generator. So this is GZ is the image generated by the generator. It is just a random value or random noise. D is the discriminator decision, and G, what the generator is trying to make that probability to be, well, make the discriminator thinks that the image is 1, which is real. So if he mislabeled it to 1, then this value will be 0. And of course, if he mislabeled this one, it will be again 0. So the generator will have what he wants, which is the loss to be as minimum as possible. Well, in this case, if you consider 1 is real and 0 is the fake, then it will be as much as possible to 0. On the other hand, the discriminator is trying to predict correctly that D is 1, which is the real image is basically a real image, and this is going to be 1. And the other one, which is the discriminator prediction of the fake image to be 0. So this portion is going to be 0. So it's not going, it's going to be, it's going to be 0. So we try to, as much as possible, here we'll have 1 and here we will have 1. So the value of V, this one, will increase as much as possible. So this is what the discriminator is trying to happen trying to do. Of course, if he misjudge the image to be, if let's say we put a fake image and we have the discriminator to be 1 in here, then this term value will be 0. So he will not get any benefit from here. And this term, of course, if he misses, and it will be 0. And this is this is not what the discriminator wants to do. So how to train this thing? In order to train it, as we train any neural network, we have to initialize, just do the initialization of the parameters. We have images to be as patches, which is also usual. However, in this case, we will, once we have a patches of real images, what we will do is we will run the generator network. Once we run it, it will start generating fake images. So now we have real data and we have fake data, fake images. Now, of course, at the beginning, everything will be random. The generator will just generate randomly. The discriminator will be also having a kind of random, or not kind of, it will have a random decision. And here it's going to be, first we run it on real data and see the discriminator decision, if it's correct or not. And of course, save it. The discriminator also will have another forward pass. However, now we will use the generated data, which is the fake data, and see the results. After that, we will compute the loss as we stated before. Once we compute the loss, now we can update the both neural networks, which is the generator neural network and the discriminator neural network, and of course by doing backpropagation. We keep doing this for a lot of times until both networks will basically um, perform well, and we will have the discriminator be full, let's say half of the time. It's very hard that the discriminator will realize that there is a difference between real images and fake images. By then we can say that the network is converged, and we have successfully trained the neural network.